Okay, GQR SPRAT Magazine, Spring 2021 edition, and we're going to talk about the Simple VFO project that I submitted and all the details inside. So this video is going to go through the full details of how to pull this multifunction VFO together, and hopefully it'll help a few of you along. Okay, let's get to it. Okay, so the Simple VFO hardware is divided across 3 PCBs. Let's start with this one. There's a button PCB, and on this PCB we've got 5 buttons, the header for the GPS breakout board, and an interconnect. That interconnect fits into the display PCB, and on here we have an encoder, the header for the TFT which goes there, and another header there which goes off to the processor, and this is the Teensy processor board. If you check on the schematic, there's multiple options to power it, either directly from the USB on the Teensy itself, or via USB here, or directly on there, feeding 5 volts directly into there, or via this header and through a regulator. Also on here we have the Teensy processor and a header for the SI5351 breakout board. So there's the 3 boards. And to get your hands on those, you need to order them from JLCPCB, and I'll walk you through that process now. Okay, so the first thing we need to do is to download all the project files associated with this project. So just navigate to my GitHub repository, and in here you'll find all of the source code associated with this file, associated with this project. The Simple VFO directory contains all of the KiCad files and a set of Gerbers for the processor board, and we've got similar files for the button board and the display board. So everything's there. We've got another directory there with all of the PDFs. Just ignore the backplane and the power meter PDF at the moment. There are future potential add-ons to this. And if you want to explore KiCad, you'll probably want to use these libraries as well. So yeah, to get all of this information, if you're not used to KiCad, all you need to do is hit the green button, download a zip, and save the entire directory tree to your hard drive. And once you've got that, you just need to unzip it all. Okay, so once you've unzipped them, the simplest way I find of ordering the boards is to navigate to the Gerbers, copy the zip files for each board to a location that you can find easily, i.e. your desktop. And then that will make ordering the PCBs via JLCPCB a little bit easier. Right, so that's the 3 zip files for each of the PCBs saved to my desktop. We can now navigate to JLC, PCB and all of them. Finding your way to JLC PCB, just type that into a search bar and you'll get a series of search results. Jump to the site. You'll have to create an account. Once you're done, it's free, it's easy. Once you've got an account, you can then upload the zip files. And we'll just walk you through that process now. Now, before I just jump into that, there's a huge amount of information on this site, like how to order things, various bits and pieces. But let's just jump straight into ordering these PCBs. So, let's quote. We'll add the Gerbers. Remember, I saved the 3 zip files to my desktop. And we need first one, it'll upload. Once it's uploaded and finished processing this board, it will give you an indication of what the board looked like. Save that to the shopping cart. Add another Gerber. Let's add the buttons next. Upload. I've kept everything at defaults. That's the button board. Save that to cart. Let's upload the third file, which is the TFT encoder screen. All of default still. Upload. Okay, so while you were waiting for your PCBs to be manufactured and posted and delivered to you from JLCPCB, you've ordered all the parts. The boards have arrived, and you're keen to construct them. So let's start off with the button board. As you can see, there's components on both sides. Buttons, obviously, the interconnect header. And on the underside of the board, you've got the GPS module with a flying lead, a few GPS antenna. I'll talk about that one in a minute. Bear in mind this is the prototype board, so there's a bit of a blodgy mess here, and I've got some additional components. Ignore all those, you don't need them. Just follow the schematics and component placements on the board and you'll be away. So it's pretty simple, that one. I'll just mention something about the puck antenna. That's the one I use, and I actually have it magnetically stuck to my gas boiler, actually, that's got partial vision out through the shack window to the sky. Satellite visibility isn't brilliant from that location, but it works a treat, as you'll see later on. And now we come to the display PCB. Again, nothing to it. Ignore that additional capacitor, it's not needed. Again, this is the prototype PCBs. So we've got the 2 headers which connect to the button board and to the processor board, and on the front side of the board we've got the encoder, push button, and the TFT display. When you're mounting this display, make sure the SD card slot is tight against the PCB, and then just solder through the standard headers as usual. having it nice and tight will make assembly into the Hammond case and the associated front panel the correct fit. And again, we'll see that later. And finally, we come to the processor board, the SI5351 breakout board. At the moment, I've only got an SMB on clock 0. Backplane header interconnect, you won't be using that just yet unless you're feeding 12 volts through into there, and then the 12 volts is regulated down to 5. You don't necessarily need to do that. Have a look at the schematic. Several ways of powering this board. That's one option. Second option is to feed 5 volts directly into there. A third option is to install a USB socket on there and feed it via USB. And finally, you can feed the whole thing via just the USB from the Teensy. One thing to note though, if you're running an external supply, i.e. not the USB supply from the Teensy, there's a track that you need to cut, which is just there. Tiny little track, and that disconnects the external supply to the USB supply, because you don't want two 5 volts conflicting. But yeah, so at the moment that's bridged, so I'll be feeding it. I'll be supplying the supply to this for a project directly via the USB. The other thing to note, I prefer these very low profile sockets. They are expensive compared to the usual breakout headers, but you can use the usual breakout headers. It just means the whole project sits a lot higher, and when you've got the button board on top, the distance between the processor, the top of the processor and the bottom of the GPS units is pretty tight, but it does fit. But there we go. So what we need to do then, once you've constructed them, is put them all together. So the first thing to do is to get the processor board, and that plugs in to the front screen. Job done. And then we've got the button board that plugs in to the button board. Job done. Now let's talk about a possible way of housing this into a project case. Okay, I like my projects to look reasonably good, and I tend to design them for a specific case. The cases differ, but I really do like these Hammond aluminium extruded cases, and all my recent projects have been designed to fit into this. So this is one that I've already done the hacking out with drills and files, but we disconnect that, come back to this assembly. This assembly is designed for the bottom board to slot into the bottom slot, and then at the top miss a slot and feed it in to there, and then the whole thing slides in. But of course, for this to work with the buttons through the case, you need to install those first, and then the bottom one and the top one is a little bit fiddly to do. But the whole thing fits in very nicely. And then, after you've done all your marking out and cutting and filing, getting the front panel in the right way round, put the fascia on, pop that on. I won't screw it on at the moment. Just use the plastic push-ins, and there we go. And then of course, just to finish it off, we need a knob for the encoder. Job done. Ignore the grill for a speaker. This is again my development case. You don't need that, but that's it, all boxed up, ready to install the software. Right, before we just jump into the software, I just need to stress I'm not a software engineer. I've just learned enough to be a little bit dangerous, and I've recently started writing my own software from a blank piece of paper. So here we go. So I'm not going to dive into installing the IDE or putting in the Teensy board support. I'm assuming you've followed the links and you've got all that installed. So when you open up my software that you've downloaded from GitHub, you'll see the main.ino file and all the associated project files in separate tabs. You can ignore virtually all of this software because you don't need to configure it, any of that. The only things you need to configure are things like the call sign banner. Put your own name and call in there. You might get fed up with the splash screen that comes on every time that the project switched on, and you can add your own splash screen by following this link and follow the instructions, and that will create a set of coefficients which are found in there, and as you can see there's an awful lot of them. You can ignore, again, you can ignore all that. So that's the only thing you need to worry about configuring in the .ino file. This file's fairly straightforward, apart from the usual sort of defines and includes and the pin definitions. We've got a setup procedure where we're initializing the GPS, we're initializing the serial, we're initializing the I2C comms, and interrupts for the encoders, setting a few default values, and then we jump into the main loop. The main loop does very, very little apart from running round and round in circles and jumping into discrete functions. Most of this is setting and releasing, or setting and resetting flags to keep the program flow correct. As you can see, I'm changing false, false, true, false. All that's to maintain the program flow. Again, you don't need to worry about any of that. The buttons tab, it's got all the button information in, speaks for itself. You don't need to modify anything, but you might see something there that you can reuse. Likewise for the S meter, there's some useful chunks of code there that you might want to reuse. Again, you don't need to worry about it for this project. You can ignore the fonts tabs. The coordinate tabs, this is where you want to configure for your system. You don't need to worry about any of these flags here, but the user parameters, this is where you start to configure the system for your own particular requirements. So if you needed a BFO frequency, for example, you could uncomment this this line and pop in the VFO BFO that you want, and that'll be coming out on clock 2. Assign any transverter offset, any IF offsets, and the VFO default frequency. Bearing in mind this project was originally set up for a transverter for 2 meters, hence we've got these figures in. But we'll come back to reconfigure it for HF shortly. And the other thing you might want to play around with, we've also got a frequency generation potential from this project. So in this area here, we can set the default frequency generated frequency and the upper and lower limits of the frequency generator. Now I've got these currently set at reasonable limits for a standard SI 5351 break-8 board, of a lower limit of 3 megs and an upper limit of 200 megs. So that's something you might want to play around with. The display functions, again, ignore it, but there's code there that you might want to look at and reuse. It's the same for the encoders. You can ignore it. Frequency generation, again, you can ignore it. GPS functions, this is where your maidenhead location is calculated and displayed, and the time, etc. is displayed. Again, you don't need to do it. So again, ignore it. The SI 5351 functions, there's some bits in here that you may want to change. So I'll quickly walk you through this. This section here is initialized and is used on the setup. You don't need to change anything there. There's two sections here. There's this section just here, which is associated with the VFO side of the software, and then there's this section here, which is for the frequency generation side of the software. So if we look at the VFO section first, remember earlier on when we were playing around and configuring the system in display coordinates.h for a BFO coming out on clock 2, if you need that functionality within this section here to implement the BFO, you'd uncomment that section there and the one below it for associated with the VFOB, and that would then run this section of code and output the BFO frequency on clock 2. So that's something you may want to play with. You won't need to do anything here in the frequency generation mode. So that's the only area that you need to worry about in the SI 5351. And the last tab, VFO and band functions, you don't need to do anything in here. There's the beginnings of some code that you might want to duplicate if you want to add your own additional bands, but at the moment that's ignored. This flag here this flag here is permanently active in the current version of software. So this section, every time this function is called, this section is implemented, is run. So the first thing it looks at is which VFO is active, A or B, and then it transfers values that you've previously set into here, which then ultimately gets used elsewhere. But you don't need to worry about any of that code, so that there's just three tabs you need to worry about. This one, to uncomment that section if you want to implement the BFO. This one here, to change these values depending on your system configuration, and just here to display for your own name and call sign. And that's all you need to worry about as far as the software is concerned. Okay, so in a minute I'll jump into configuring these areas here, compiling and downloading each version into the hardware, and I'll show you what the display looks like, just to give you a feel for what you can do. Okay, so let's look at the configuration of the system as it comes straight out the box. We'll leave the call sign and name at the moment as to GQRP SPRAT. We'll leave the BFO off. The transverter offset remains at 116 meg with a 9 meg IF offset and the default VFO. So we'll leave all those standards. We'll just make sure that we've got a Teensy board identified and it's sat on there on the right port, and we'll compile and upload the new software to the project, and then this is what it will look like on the hardware. That's the splash screen. Contrast is a bit sharp at the moment, a bit clearer when you see it. That's the opening up screen with the default frequency, and as soon as the GPS locks on, you'll see the lat long and time and date displayed, along with your maidenhead, and it'll cycle then through to your name and call sign. Alright, let's see what it looks like for, and those cycle round and round. Let's see what this looks like configured for 20 meters. Let's assume you've got a 20 meter direct conversion rig on your bench, and we need to configure this software to implement that hardware. So we don't need a transverter offset, so we'll set that to 0. We won't need an IF offset, so we'll set that to 0. And the default frequency will be, let's use the international QRP calling frequency of 1406. That should do everything we need to do. So I now need to, let's just change name and call sign. And that's download the code to see what happens. Okay, new code's being uploaded. Splash screen, and there's our new VFO frequency for our direct conversion project. And as you can see, time and date, GPS is all locked on, and we should see the new call sign displayed. Yeah. Job done. Right, let's discuss the functionality, the operation of the hardware. So you can see we've got 5 buttons, 4 navigation buttons, and a command button. Now at the moment you can see a very small line here. That's indicating where your frequency increment is. If you wanted to go up or down, turn it down, it jumps down, down again, or we can jump up. So it's pretty straightforward. To change VFOs, we can change it like that, swap back, and away we go. Very, very straightforward. If you wanted to lock any particular frequency to stop any knocks on there, you can click on there, short click, and then that locks the frequency. You can't do anything with it. And then to unlock it, press again, and away you go. To enter the signal generation mode, press on the encoder button. Exactly the same functionality. Change low. And there. Bottom one comes out on clock 2. Top one comes out on clock 0. What more can I say? And to return, push again, and away you go. Now at the moment the input to the S meter is floating, so hence the reason it's getting random numbers. But you can see there's a very nice rainbow coloured implementation of signal strength. That's all within the software. Look on the schematic to find the input pin and input the voltage from your circuitry, making sure you don't exceed 3.3 volts onto the input to the ADC. Everything should be good. Well, I hope you enjoyed that. Let me know if you build one. Always pleased to hear from people. Have fun and happy home brewing. 7-3.